Well, good morning, everybody, and thank you for joining us. My name is Joshua Karasak. I'm a winemaking specialist with Enartis USA. And this morning we're going to be presenting on tannins and polysaccharides for aging. So just a little bit about the presentation before we get into it. If you've never been in one of our webinars before, welcome. And so we're gonna do kind of a technical and practical presentation today. Within the presentation, we don't usually answer questions or address questions. At the end of the presentation, we'll have a specific segment for questions and answers. So you'll notice on the right-hand side of the viewing pane here, there is a area or a chat box where you can write questions. We just ask that you refrain from asking questions until the very end. So hold your questions till the end, and we'll have about 15 to 20 minutes to answer those questions once we get to that point. So I do recommend just having a pen and paper to write down those questions in case they come up during the presentation. So, as a general overview for the presentation today, I'm going to go over enological tannin production, so a little bit about how tannins are made. We'll then talk about the different kinds of enological tannins that are available in terms of classifications, the most common ones that you'll find in winemaking. Then we'll talk about tannins for aging, how you can use tannins to be used in wines for aging. Typically, winemakers will think of using tannins at the end of the process, just before bottling, but they can actually be very useful in the actual aging process as well. So I'll go over that for a little bit. Then we'll go into yeast polysaccharides. Generally speaking, I think that this is one of the more underutilized tools in the industry. And so I'm going to just quickly go over how they can be used, what they are, and then how we can balance a wine between these two different tools. And then I'll have a couple of slides on bench trials as well, and how you can sort of easily do bench trials. So enological tannin production is a process that relies on a couple of different technologies. And the way that I typically think about how tannins are made is you kind of have to think of it like you're making a tea almost. So with tea, you have a teapot that you fill with water, and you'll boil that water, and then you use that hot water to pour over the tea bag and make the tea. Tannins is kind of a similar process. So you have an extractor, which would be like your teapot. You have a solvent that will be used to extract the tannin itself, and that could be water or it could be ethanol. So just depending on the kind of tannin you're trying to make, you can choose a different kind of solvent. The extractor may or may not have temperature involved, so it might be a hot extraction, it might be a cold extraction. And then the matrix, which would be like your tea bag in the case of making tea. But the matrix in terms of wine enological tannins can be a lot of different things. Could be oak in terms of French oak or American oak. Could be tara pods or even gallnut. So it could be a lot of different things. The matrix basically though is what you're extracting the tannin from. And then the solvent is your sort of liquid base that you're extracting that tannin into in the extractor. So you go through the extraction step. You basically either with or without temperature, you use your solvent to take or remove the tannin that you're looking for from the matrix. And then that gets concentrated either through vacuum removal or through heat. So you concentrate that down until you have basically little to no liquid. And then it goes through an atomization step, which basically turns it into a dry soluble powder. So that's kind of how enological tannins are made. And so in general, it's basically a pretty simple sort of process, but there's a lot of different variables in terms of the kind of tannins you can make, just depending on the choices that you make in terms of the process. So with or without heat in the extractor, with or without water or ethanol in terms of the solvent, the kind of matrix that you're starting with, the kind of concentration you're doing, all of those steps will yield a different result in terms of the tannin from a sensory standpoint and and also from a technical features kind of standpoint, and how the tannin sort of performs in wine for different purposes. So that's just a little bit about how tannins are made. So in terms of our tannin matrix, we have a lot of different sources that we can pull tannin from. And there's different classifications of tannins in terms of their activity and what they do. Mostly when you're looking at enological tannins, you're looking at gallotannin or gallic tannin, elagitannin, or condensed tannin. So gallotannin is typically derived from oak gall. So if you've ever seen an oak tree that has like those little kind of balls that can that fall off of the tree, that typically has a really high content of tannin, so gallic tannin. Tauropods are another good source of gallic tannin. And I'm not going to really get into the chemistry of phenolics and all of that, just in general, because it can be kind of hard to follow in a presentation. But I'm just showing you some of these phenolic structures to show you that there's big differences in terms of the structure of the phenolic from the different kind of tannin. So not that this is going to play any sort of role in terms of how we're going to select the tannin. What we're really looking for in terms of winemaking is what is the sensory purpose of the tannin and how is the tannin going to perform in the wine. So that's gallotannin. So it can be useful for anti-radical, for oxidation purposes, and also as strong antibacterial or microbiostatic features as well. Elagitannin, this is what you typically get when you're using oak. So if you're doing oak aging, you're sort of naturally getting elagitannin from that oak. And when we're doing an extraction of oak, and when we're making tannin, we're making an elagitannin from that. Elagitannin can be used for a lot of different reasons. It certainly has its own mouthfeel kind of contribution, and its sort of technical features are that it can help with color stabilization. Basically anything that you can think of that oak aging contributes to a wine is basically what elagitannin can add as well. And then condensed tannin, this is coming from grape skins or grape seeds. Depending on the source, either the skin or the seed will depend on the kind of condensed tannin you're getting. But generally speaking, it's the primary tannin in red wines. And so generally speaking, it's these long sort of chains of these phenolic groups. And again, depending on the kind of source of condensed tannin you're looking for, either skin or seed, you'll have different performance in terms of how the tannin is perceived on the palate, and then also some of the technical features of the tannin. So that's sort of a general overview of the three different kinds of tannin groups that we most commonly see in enological tannins. In terms of categories of tannins, Enartis has a pretty big range of tannins that it offers for different purposes in terms of the sensory impact of the tannin, and also in terms of some of the technical features that come along with that. So how do you decide which tannin you want to use when you're looking at a large portfolio of tannins? Well, one thing that you can start with is, what is the wine style objective? So what kind of wine are you trying to make, and how are you trying to adjust the wine from a sensory standpoint? Is the wine lacking in structure? Is it lacking in mid-palate? Is the finish just a little bit off? And then ultimately, what kind of wine are you trying to make? Another question you might ask yourself are, what are the current tannin levels? So is the wine already quite tannic, or is the wine sort of lacking in astringency? Is the wine, what are the current tannin levels you're working with? Because that's going to sort of guide how you choose your tannin for a sensory purpose as well. Obviously, if you have an extremely astringent wine, you're not going to want to look at using particular kinds of tannins. So just keeping in mind what your current tannin levels are is important. And then the third category I would say is, what are any additional technical features you're looking for out of the tannin? So tannins are added for their mouthfeel improvement purposes, but many times there's actually a lot of additional technical features that come along with using that tannin as well. So those are important things to consider too when you're making a selection. So I just wanted to highlight a specific tannin in our range that I think is really popular and is also very useful for many reasons. So if we're thinking about using tannins for aging, one thing that we can consider is that if we're using oak primarily, and we're looking to maybe switch to doing tank aged wines with micro-oxygenation, or we're just looking to get a little bit more oak impression out of our wine through neutral barrels, or if we're just basically not getting enough oak presence, or looking to just adjust oak a little bit before aging, this would be a good one to start with. So it's a light toasted seasoned French oak. And the French oak that we're sourcing for this, in terms of the matrix, is actually the same kind of French oak that you're seeing in oak barrels. So we're sourcing very high quality, light toasted seasoned French oak for this. And we're extracting the tannin to sort of give a little bit of boost to the mid palate. Also, the tannin itself is kind of a soft, kind of velvety kind of mouthfeel texture. And then you also get an aroma contribution typically, which I attribute to kind of a spice or cola kind of note, vanilla or caramel. And then we also see other technical benefits out of this tannin in terms of color stabilization. So this was a nice experiment that was conducted at UC Davis from Anita Oberhoster. And what she did is she looked at total polymeric pigment evolution and different wine treatments. So this red treatment right here was barrel American oak aged barrel aged wine. This was barrel French oak aged, and then this was this purple one was micro-oxed. This light blue one was micro-oxed with chips, and this orange one was with staves, and then finally this last blue one was with tannin, and specifically it was with the Coeur de Chêne tannin. And you can see they measured the formation of polymeric pigment or stable color over the course of time, and so 3 months, 6 months later, you can see there's a pretty good difference between the tannin compared to the other oak adjuncts. And so I think it's pretty evident that the tannin has a pretty strong impact on color stabilization. So in terms of aging, if you're trying to age a wine and produce a wine with stable color, this might be a good option in terms of stabilizing color and also just giving some oak impression. So pretty nice results from that particular study. The next sort of classification I want to talk about is condensed tannin in the form of grape-derived tannin. So tan uva is a tannin that's basically derived from mature white grapeseed. So this is a seed-based tannin. If you're thinking about a wine that maybe has been, so for instance, if you had a smoke event and you were trying to limit extraction with that smoke event, and your red fermentation, and so you weren't getting quite enough mid-palate or seed tannin from that, that's where you look to a tannin like tan uva before aging in order to give you a little bit more grip or a little bit more structure. So I think this is a structuring tannin. It tightens structure and fills mid-palate. It kind of just tightens things up in general, and gives a little bit more complexity to the mouthfeel of the wine. And then in terms of aroma, I would say that the nice thing about using grape-based tannin compared to oak-based tannin is that you do get a different kind of aromatic contribution from using that tannin in terms of this sort of black tea or spice component that comes along with the use of the tannin. Other benefits with that are also related to color stability. So condensed tannin in the form of seed-based tannin can help with color stability as well. This was a study done comparing, again, oxygen with different treatments, and for example, comparing a control and a pro-anthocyanin, and this was seed tannin. You can see that the total condensed tannin increased with the addition, but also increased the polymerized condensed tannin over time, as well as combined anthocyanin percentage. So we had a higher amount of polymerization of tannin with color. So again, this is a technical feature. It's something that is a benefit to using the tannin. Primarily, we're using it for structuring and improving the mouthfeel. But another technical feature that's added to it is color stability. So now I want to switch gears a little bit and talk about a new tannin. If you're part of our email list, you probably just saw a notification about this one, and we're pretty excited about it. It's Hideki. So Hideki is basically a blend of the 3 different types of tannins that I mentioned before. It's gallic tannin, ellagitannin, and condensed tannin. From a mouthfeel standpoint, this is actually fairly neutral in terms of its impression. And from an aromatic standpoint, we're also not getting a lot of aroma. It's actually, it's features that are highlighted, or its actual technical use in terms of it being microbiostatic and antioxidant in those technical features. So while the mouthfeel is not its main highlight, its technical features are actually quite interesting. So in terms of its microbiostatic action, it actually can help to prevent acetic acid bacteria growth. So this was looking at an initial inoculation of acetic acid bacteria in a lower SO2 wine. So 4 ppm of free SO2 is pretty low. And this is a red wine, and basically one with the 5 grams per hectoliter of Hideki, and then the control without treatment. And you can see that the acetic acid bacteria is able to proliferate in the regular control wine with lower SO2 over time, where the Hideki control or the Hideki treatment was actually preventing the growth of the acetic acid bacteria. So it's a beneficial tannin for that reason. That's able to actually it's a microbiostatic effect in terms of its technical feature is that it can prevent the growth of acetic acid bacteria in lower SO2 wines. Another technical feature of this tannin is its antioxidant impact. So in terms of this trial was looking at the impact on yellow color increase or browning basically. So this y-axis basically translates to the percent increase of 420. And you can see that the control basically increased quite a lot. The SO2 addition that was done basically had a strong impact on reducing this browning. So this was a full saturation of oxygen in the wine, and then treatment with different amounts of SO2 and Hideki, and then measuring the yellow or browning increase over time. And what we saw is that the SO2, of course, was able to limit some of the browning increase, but Hideki also was able to basically reduce some of the browning at 5 grams per hectoliter. And then the combination of a small amount of SO2 and Hideki actually had an even stronger impact. So this might be a really good solution for wines that are lower SO2, or you're trying to lower SO2 levels, is this combination of lower SO2 and the Hideki itself. So pretty impressive results, and we're pretty excited about some of the technical features of that particular tannin. So another thing to consider, if you're looking at the technical application of tannins for selecting which kind of tannin you want to use, is you might want to look at the effect on protein precipitation, the antioxidasic effect, the anti-radical effect, the effects on redox potential, mercaptan removal, metal chelation, color stabilization, antioxidant effect, microstatic effect. So this is just sort of a table that was pulled from our most recent newsletter on this particular topic, so you can find that on our website. But just keep in mind the different kinds of groups of tannin and their technical impacts on the wine as well. So within that same newsletter, we had some good information on which tannins in our range will give that desired impact. So I do recommend checking that out if you're trying to figure out what's the best tannin for your wine. This is a good place to look for the technical features of our products. And I'm actually sharing that. I'll share that link with you at the end of the presentation, so you have that available to you. So yeast polysaccharides. Now I'm going to sort of switch gears and talk about something that I think again is an underutilized tool for the wine industry, and I think that the industry can benefit a lot from looking at these yeast polysaccharides. So if you're doing batonnage or surly aging currently, you're probably already aware of the beneficial impacts of yeast essentially on wines as they age. The way that I usually describe the effect of batonnage or surly aging is an increase in the mid palate of the wine or weight of the wine. It tends to soften out some harsh acidity, so acidity that tends to be a little bit too aggressive. you can generally sort of spread out the acidity and lengthen the perception of the wine as well with this kind of treatment to wine. So batonnage or surly aging, if you're not familiar, is just periodic resuspension of the yeast that is settled in a barrel. And that periodic resuspension does a couple of things. One, it can basically mop up any oxygen that might be excessive in the wine, as yeast cells have the ability to basically absorb oxygen. In particular, when you're in a low SO2 situation, yeast cells have a capacity to be able to basically absorb oxygen from the wine. So that's one feature. The other feature is that when you resuspend the yeast in the wine, what you do is you basically expose the wine or expose the yeast cells to the wine. And what that does is helps break down the yeast cells over time and sort of releases some of the beneficial components of the yeast cells into the wine. And I'm going to sort of discuss a little bit about those different types of yeast components and which ones are important for wine impression as well. So when we're talking about enological yeast derivative types, there's three main types that you typically see. You see autolyzed yeast. Autolyzed yeast are basically yeast that are broken down to some extent either with enzyme or acidic treatment. So basically kind of pops little holes essentially inside of the yeast cell and breaks down some of the yeast cell wall. Yeast holes or yeast ghosts are essentially kind of like the outer shell of the yeast, just sort of taking the outer shell while the inside is relatively empty. And inactivated yeast are basically yeast that have been killed essentially, and they're essentially inactivated at this point. They're no longer living. So it's sort of the yeast itself is dead essentially. And you can have some combinations of inactivated yeast that are autolyzed as well, so that they're basically broken down a little bit more than you would typically see in natural yeast lees. And then manoproteins, as I'll get into in a couple of minutes, are basically constituents of the cell wall that you can sometimes pull off of the yeast cell as well. So manoproteins have their own set of beneficial side effects, and I'll talk more about those as well. But essentially what we're looking at when a yeast cell is breaking down over time, you start with something that's an inactivated yeast, and then over time you have these sort of manoproteins and polysaccharides that eventually sort of fall off of the surface of the yeast cell. So when you're getting an enological yeast derivative, essentially we're sort of doing this work for you as a winemaker. We're inactivating the yeast, and we may be doing some autolyzation to make that yeast break down a little bit faster, or actually release some of the beneficial components more quickly. Or we may actually be just taking some of the manoproteins, some of those polysaccharides directly from the yeast, and concentrating or making a soluble version of those manoproteins. So they're really useful tools to winemakers for many reasons, but basically there's different classifications that are available to winemakers currently. So a little bit about manoproteins specifically and what they are and how they impact wine. So if we pretend that this is a yeast cell right here, if you were to kind of zoom in on the surface of the yeast cell, you would see that there's a network of polysaccharides that make up the cell wall on the outside of the plasma membrane. And there's different kinds of polysaccharides within that sort of network that protects the yeast. And the one I'm going to sort of focus on in this presentation, which are really important for mouthfeel features and for also technical benefits to the wine, are manoproteins. So manoproteins are polysaccharides that are embedded sort of in the surface of the cell wall. So that's just kind of an overview of what we're looking at here. So yeast manoproteins are generally 80 to 90% mannose, 10 to 20% protein. So it's a complex of protein and sugar. It's about 40% of the yeast cell wall in weight. So it's a pretty large component of the yeast cell wall. It's negatively charged, so that gives it really a lot of features in terms of how it interacts with wine colloids. So it interacts with other wine colloids, and so anything that's charged positively can have an interaction with this negatively charged compound. It improves tartrate stability, so it's able to actually make tartrates more stable, and that's actually it's allowed use in wine in terms of manoproteins are actually specifically used for tartrate stabilization, although they do have other benefits in terms of the impacts on mouthfeel and things like that. So they do limit tannin aggregation as well. So you can see, so basically on the y-axis here, this is the size of aggregates of tannin formed. This increasing number is basically the larger size of tannin aggregation. And these different lines, or these different plots basically represent increasing amounts of manoproteins. And you can see, so this is the lowest amount of manoproteins concentration right here. So you get fairly large aggregation of tannin in that treatment. And then as you increase the concentration of tannin, you actually see less aggregation. So basically, manoproteins have an impact on the aggregation of tannins, which makes them particularly interesting from an aging standpoint because tannins tend to change size over time in wine. They tend to polymerize, form larger aggregates. So, you know, this is a tool that winemakers might be able to use earlier in the winemaking process to sort of drive some of the way that the wine is aging. So that's just sort of a little tidbit of information on how manoproteins affect tannins. And then they're usually released in two phases during the winemaking process. So during fermentation, you get a good chunk of them out of the fermentation itself, and then during surly, which is sort of autolysis after fermentation is complete during aging. So I want to talk about two specific products in our range that can benefit winemakers from an aging perspective, and that's Surly 1 and Surly Elevage. So both of these are inactivated yeast. Surly 1 in general is generally used earlier in the winemaking process. So this is just sort of after fermentation when you would consider using this particular product. You can also use it, you know, as a wine is starting to finish fermentation. And then Surly Elevage, generally speaking, releases manoproteins a little bit faster. And so this one can be used a little bit later during aging. So in terms of their particular use, one thing that you can do with the Surly range is actually shorten lees aging. So fermentation lees in general take about 6 months to actually release the full amount of manoproteins that are on their cell wall because it just takes time for those natural yeast lees to break down. Surly Elevage, when we add that into a wine, about 65% of it is released immediately. And then about 3 weeks later, we have the full extraction of the polysaccharides from the cell. And then Surly 1, we have a little bit longer release of those manoproteins, which is why we typically want to get them into the wine as soon as possible to get that impact on mouthfeel. So, but this essentially can shorten the lees aging period significantly. So if you're doing batonnage or Surly aging, this can actually reduce that period of waiting. And then also, if you can think about the technical features of having manoproteins in the wine earlier, you can start to think about how this could basically potentially change the way your wines age from a astringency standpoint or from a color stability or tartrate stability standpoint. Having the manoproteins in the wine earlier can make a difference. So other situations where yeast derivatives are helpful. So one particularly important thing is when you have reduced lees. So after fermentation, if you have reduced natural lees and you don't want to use those lees or keep the wine on those lees, what you can do is you can actually rack off of those lees and remove them and then supplement back into the wine Surly 1 or Surly Elevage. And that will basically prevent those reduced lees from re-releasing sulfur compounds into the wine over time. So that's one possible useful application of the yeast derivatives. Another thing is with smoke tainted lees. So if you've had a wine that has smoke taint, the gross lees after fermentation tend to be quite smoky. And if you want to get your wine off of those lees as soon as possible, but still want to have some lees aging, then you can also use yeast derivatives in that perspective as well. Brettanomyces, in some cases, Brettanomyces might be removed through filtration, or if you've racked off, done a heavy racking to try and get the wine off of the Brettanomyces lees, then this might be a good time to use and supplement back in some yeast lees to give the wine some body. Some winemakers will actually cross flow and remove as much yeast as possible if they have Brettanomyces, and in that case you would also want to supplement back in some yeast derivatives to try and give your wine a little bit more weight and body. And then other off flavors and aromas that might appear. Yeast lees are a great way to kind of sop up some off aromas and flavors that can develop in wine. Sometimes the natural lees that you have in a wine too might just kind of smell funky. And in that case, you don't want to keep the wine on those lees. You want to kind of get the wine off of it. And that's another case where you would want to supplement back in with some Surly 1 or Surly Elevage. Another thing to consider, as winemakers is balancing a wine. So I tend to think about this sort of teeter-totter, where we have tannin and acidity on one side, and we have ethanol, sugar, and polysaccharides on another side. So tannin and acidity, if we have too much tannin or too much acid, we have this sort of bitterness, astringency, or sourness, and then the descriptor that comes along with that wine is that it's hard or green or coarse or unripe. We can balance those kinds of wines by increasing the polysaccharide content, the sugar or the ethanol. Generally speaking, I think polysaccharides is a good way to do this. And the other sort of converse sort of situation, if we have a wine that has too much of this sugar, polysaccharide, ethanol kind of content, then we end up with something that's more sweet in terms of its perception, and we would consider those wines to be like fat or flabby or thick, basically just not enough structure. And in those cases, we might adjust the tannin or acidity to try and push that wine back into balance. And when we get balance, we have wines that, from a mouthfeel perspective, are more silky, velvety, or ripe sort of characteristics. So, as a winemaker, if you're getting to the early part of the process right before aging, and you're finding that the wine is just too much on this sort of tannin or acidic sort of side, you can use polysaccharides to try and balance that wine. And vice versa, if you have a wine that sort of has not a lot of structure and it feels like it's kind of lacking in the mid palate, that's where tannin can kind of play a role as well. So Enartis has put together a nice sort of leaflet or brochure that has a couple of wheels to help guide winemakers to the best kind of tannin or polysaccharide for their specific goals. So when we're talking about aroma improvement, there are different sort of categories that we look at. We would talk about spicy sort of notes, red fruit, the fresh fruit kind of notes, more neutral tannins or oak character. And if we're looking for more oak character, we would look to this group of tannins right here, the Unica 1, the Tan Toff, Tan VNL, which is our former Tan Vanilla, or Tan Mel. So any of the tannins in this group would be useful for oak character. If we're looking for spicy character, we would look at these tannins. For red fruit, we would look at these tannins. So I'm going to share this document with you after this presentation, so you have it. And if you're kind of overwhelmed by the number of options within our portfolio, this can help kind of guide you towards the selection of the tannin specifically. If we're looking at improving mouthfeel, here's another wheel that's included on that in that brochure. Sort of looking at reducing burning sensation, reducing bitterness, reducing acidity, increasing balance or structure, increasing volume, reducing astringency. And so this outer green line right here are enological tools that can be used anytime from early maturation to bottling. And then this yellow ring on the end side is used for early maturation. So if you want to reduce burning sensation, you can use the Surly Elevage, reduce bitterness, the Surly 1, reduce acidity, Surly Round. So this is in general just a good guide in terms of selecting the right tannin or the right polysaccharide for your specific wine balance. And then finally, the technical application of the tannins and polysaccharides. So tannins can be used to treat reductive notes. You can also use polysaccharides for the same purpose, preventing light-struck wines, freshening oxidized wines, reducing herbaceous notes, preventing oxidation, helping color stability. So these are all technical features that come along with using these particular tannins. And so same sort of guidelines, the early maturation ones, the ones that you're going to use just in maturation are going to be in this sort of yellow kind of ring, and then the ones from early maturation to bottling are in this green ring right here. So in general, just kind of a useful visual guideline to selecting tannins within our portfolio. I sort of want to touch base real quick on bench trials. So bench trials are one of the more useful tools in a winemaker's sort of skill set in order to fine-tune wines with yeast polysaccharides or tannins. And in general, you just need sort of a brief sort of list of items in order to make this happen. Usually a pipettement of some sort, usually a P1000 is a good one to start with if you don't have one already. Some 100 milliliter bottles, a scale that goes to at least 1/100th of a gram, your tannin or polysaccharide samples with technical data sheets. So if you would like to try a tannin or polysaccharide within our range, you can always reach out to us and we can actually send you sample sachets of those tannins or polysaccharides for you to try for yourself. You probably need some beakers and wine glasses as well to do the tasting. And then I would recommend using our bench trial calculator that's on our website as well. That helps with calculating some of the additions for bench trials and helps for that reason. So keeping those items in mind, this is sort of the process that you're going to go through in order to do your tannin or polysaccharide trial. So first thing you're going to do is you're going to weigh out 1 gram of your tannin or polysaccharide. And you're going to make basically a 1% solution of that tannin or polysaccharide. Usually I use a 13% alcohol base when making this solution. So you can use like a high grain alcohol, or you can also use like very neutral base like vodka or something like that. And you make a 13% water solution, or 13% alcohol solution. And then you use that solution with this tannin or polysaccharide to create a base solution. So you're making a 1% tannin or 1% polysaccharide solution with that hydroalcoholic 13% solution. So then what you're going to do is basically with that 1% solution, you're going to figure out what kind of dosage rate you're looking for to treat your wine. So there's different dosage rates for polysaccharides and for tannins, and you just need to refer to the technical data sheet on that particular item before you start your trial. So for instance, if you're working with a tannin, you would get your pipettement, you have your 1% solution, and let's say you want to do 2 grams per hectoliter of a dosage. What that amounts to is 200 microliters of your 1% solution, and you're going to add that to a 100 milliliter sample size. So again, the bench trial calculator can help with calculating exactly how much you need to add in order to do these bench trials. But let's just say you're starting with the 1% solution and you want 2 grams per hectoliter. You would need 200 microliters in order to meet that dosage in a 100 milliliter sample size. Similarly, if you wanted to do 4 grams per hectoliter, you would just double that dosage to 400 microliters of the 1% solution in your 100 milliliter sample size. And then let's say you want to do 6 grams per hectoliter, similar thing, you just increase the dosage or increase the volume of your 1% solution dosed into your 100 milliliter sample size. So depending on your sample size and depending on your dosage, it will change the amount of this 1% solution you're adding to that sample. So in general, that's how these tannin or polysaccharide trials are done. You get your base solution of tannin or polysaccharide, usually 1%. Sometimes you can do a 5% solution too if you're working with higher dosages or working with a larger sample size. Sometimes that makes sense to do a 5% solution or even a 10% solution. I usually work with a 1% solution. So it's 1 gram of tannin, basically like 99 milliliters of that hydroalcoholic solution. And the reason why we're doing a hydroalcoholic solution rather than just doing water is that we're trying to basically match the alcohol level of our wine that we're dosing. So we usually do like a 13 or 14% alcoholic solution with the tannin to try and match the body better of the wine that we're treating. So that's how the bench trials are basically done. It's pretty simple. After you've dosed with the tannin or with polysaccharide, you can usually taste, right away, essentially. And the tasting will give you the impression of the aroma or the mouthfeel impact of the tannin itself. So some takeaways that I hope that you'll take from this presentation is that not all tannins are the same. And, enological tannins are a bit of an art in themselves in terms of, how they're made and their features. So please, when you think about tannins, try to understand, how the tannin is going to perform in your wine before you go ahead and use it. Finding the right tannin for your wine can be challenging. So to narrow your selection by defining your objective goals that I presented earlier. So what is the style objective of the wine? What are any extra technical features that you're looking for? What's the tannin content of your wine currently? That's going to help you sort of narrow down which tannins to look at. And then oak and grape-based tannins can be both used in aging to improve sensory properties and benefit the wine quality. So it's not something that a lot of winemakers are currently thinking about, but tannins can be a really nice substitute for for oak aging in barrels. And also, in terms of using them instead of even oak staves or oak chips. So, consider tannins to be another tool in your tool belt in terms of, tannins that you can add for aging. And then Enartis has tools to aid in finding the right tannin for tannin or polysaccharide for your objectives. So if you ever feel overwhelmed with looking, for the right tannin, just feel free to call us. We're happy to help guide you. And we'll also provide you with, sort of materials that can help guide your selection for the right tannin. And then bench trials are a great process for testing sensory impact of tannins and polysaccharides. We highly recommend, getting a good bench trial set up in your lab because it's really going to make the process a lot more easy to do. And bench trials in general can be a really fun sort of part of the process in terms of, fine-tuning your wine and trying to find the best possible, enological tool for your wine. So I want to thank you for watching this presentation, and now we're going to probably start the question and answer portion of the webinar. So if you have any questions about tannins or polysaccharides in general, feel free to type them in the chat box, and I'm happy to answer them as they come in. So if you have any questions after the webinar as well, you can feel free to reach out to me at my email here. Or just feel free to call the main Enartis USA branch and ask them to put you in contact with me, and I'm happy to help you outside of this webinar as well. So yeah, let's go ahead and get to some questions if we have them.